So let us formally talk about the relations. What do we mean when we say relations? See, as I indicated earlier also, the relationship between you and your brother is what? Is an example of relation. So just consider two sets. This is ABC and this is Ali, Bhanu, Binoy, Chandra and Divya. They are represented or they are also shown in this visual representation. This is P and this is Q. So the Cartesian product of P and Q is what? How many members you are going to get? In P you have 3, in Q you have 5. So how many you are going to get? 5 into 3, that is 15 members. So the Cartesian product will be 15 members. But as I am introducing the relation, please understand that these 15 members in the Cartesian product, the relation will be in this Cartesian product. So we are going to take some ordered pairs from the list of Cartesian product, and then we will say, okay, this is the relationship. Okay, let us introduce a relationship. Say this is a relationship where between this P and Q, where the first element X and the second element Y of each are ordered pair such that the XY in this XY, X is what? X is the first element and Y is the name which starts from this alphabet or the letter. So X is the first letter of the name Y. So A, let us see, only Ali corresponds to A or qualifies for A. So first will be A comma Ali. The relationship we are talking about now, we are not talking about Cartesian products. Cartesian product is the list of all the product possible, but the relationship is those who qualify in that Cartesian product are taken. So A, Ali qualifies with A. Now B, let us see B. So we have two, Bhanu and Binoy. Bhanu and Binoy qualifies with B, B comma Bhanu, B comma Binoy. What about this third one, Chandra? So C comma Chandra. And please observe that Divya was not at all taken because there is no D. There is no D here. This is what relationship is all about. So now this is the set and these are two set and this is the result of your relationship. So let us formalize it. Our relation R for any non-empty set A to a non-empty set B. So for A to B, that is A has to be non-empty, B has to be non-empty, is actually a subset of Cartesian product. As you have seen in the previous discussion that 15 possible ordered pairs were there, but only 4 qualifies to this relationship. So the subset is derived by describing a relationship that we just saw. The first element and second element has to have some relationship, and that will be represented in the form of ordered pair. The second element is called the image of the first element. I'll tell you about this. Image, domain, I'll tell you about this because these are very important. Image, domain for those who are actually preparing for IITs and entrance exam. For this image, this domain, range, codomain is very important. So the second definition is the set of all first element of the ordered pairs in relation R from a set A to B is called the domain. We'll see about this. The set of all second elements in the relation R from set A to B is called the range. The set of all second elements is range. The set of all first element is the domain. So domain, set of all first elements, range, set of all second element. But these two elements has to qualify into the relation R. And all the element, whole set B, this second set, all the elements of this is known as the codomain. So we essentially deduce that range is a proper subset of codomain. So a relation may be represented, can be in either form as we saw these sets. It can be represented in the roster method or by the set builder method. And we'll see the visual representation also. First, let me tell you with an example that what exactly we mean when we say that one thing is your domain, codomain, range. So this is a set 1, 2, 3, 4, 5, 6 member are there, and we want to define a relationship from A to A. Means both the sets are same. First set will be 1, 2, 3, 4, 5, 6. The second set will also be 1, 2, 3, 4, 5, 6. So the relationship x comma y will be like this: y is equal to x plus 1. So the second member should be one addition to the previous one, or one in excess of the previous one. So let us draw this in arrow diagram. First we'll by definition let us write 1 comma 2. See, 2 is 1 plus 1, 3 is 1 plus 2, 4 is 1 plus 3, and 5 is 1 plus 4, and 6 is 1 plus 5. See, this is how we make it. Okay. So what we are going to get here is, in the relationship, we'll first make a representation here. So see, 1 with 2, 2 with 3, 3 with 4, 4 with 5, 5 with 6. Why I uttered all these relationships or all these pairs? Because I want to see, or I want you to see or observe that 6 is not taken, 1 is not taken. So here comes our second part. We can see that the domain is 1, 2, 3, 4, 5, 6 will not be included in domain. So all the elements of the first which are included in the relationship is the domain. What about the range? You see in the second one, this one is not taken. So all the elements which are in the second set, which are taken in the relationship, is the range. So range will be 2, 3, 4, 5, 6. What about codomain? Codomain is the set, this whole set. This B set, you can say, is the codomain. Let us take one more example. This is your figure. So this figure shows certain relationship between P and Q. And you need to write the relationship in the form of set builder or the roster form. And you also need to tell about the domain and range. So let us see how. First, it is but obvious that this 9 is the square of, means 3 square is 9, and minus 3 is also 9. Similar for 2 and similar for 5. So this is actually a square relationship. So let us write it first. X is a square of y. Set builder form will write x comma y, where x is a square of y and x belongs to P, and the second one, this y belongs to Q. This y belongs to Q. Okay. Now this we have just seen, x belongs to P and y belongs to Q. In the roster form, we'll write the proper values or ordered pairs. That will be 9, 3, 9 minus 3, 4, 2, 4 minus 2, 25, 5, and 25 minus 5. The domain is what? The domain is, let us see. In the relationship, 9, 4, and 25 are included. So we say that 9, 4, 25 is the domain. What is the range? See, only 1 is not taken. So this 2, 3, 5 and minus 2, minus 3, minus 5. This is going to be your range. So this is the domain and range. What about the codomain? The complete set including 1 is the codomain. So let us see one more thing, that the total number of relations that can be defined from set A to set B is actually the number of possible sets of AB. So if the number of elements in A is P, number of elements in the set B is Q, and the number of elements in A cross B is, of course, we know by now that we just have to multiply the element of 1 with 2. The total number of relations which are possible is 2 to the power PQ. This is very important. This is generally asked in questions paper. So this is 2 to the power PQ. Let us take one more example related to this, what we have just learned. Let us have a set A, 1, 2. B will contain 3, 4. We need to find out the number of relations from A to B. So we say we have A cross B is 1, 3, 1, 4, 2, 3, 2, 4. The number of elements in this set or this relationship is how many? 4. So the number of subsets which are possible is 2 to the power 4. 2 to the power 4. Thus the number of relationship from A to B will be 2 to the power 4. So relation R from A to A is stated as a relation of A. Say we are talking about A and B here differently, but when we are talking about same set, a relationship of your family with your family, That means a relationship of me with myself. So relationship of A to A is also stated as a relation on A. So now we have seen a lot about relation. Next discussion we are going to take the functions. Till then, thank you so much. Take care of yourself.